Hello viewers, we're taking you through the story for A-level mathematics, and in this video we're going to go through the marking guide of Senior 5 of Math End of Term 1 2023 of one of the schools. So this video is suitable for students in both Senior 5 and Senior 6 offering mathematics as part of their combination. So before we start, let's first look at the books which are needed in A-level mathematics and physics. So in total there are 4 books. There is Math Paper 1, Math Paper 2, and Termly Papers. These ones include for the previous years, beginning of term, mid-term, end of term, sets of mocks, and UNEB marking guides from 2022 to 2010. Then this one is a topical question bank. So all these 4 books are necessary in A-level, and if you need a copy, contact the author on this contact or send a WhatsApp. The same applies to physics. There are 4 books. There is Physics Paper 1, Physics Paper 2, and this is the topical question bank, and these are the solutions found to the questions found in this topical question bank. So those are the 4 books needed in math and 4 books in physics. When you get them, then you are good to go. Otherwise, I welcome the S5s from term 1 of A-level and hope it was a good experience. So now we shall go through these questions. Now, because few topics were done in Senior 5 term 1, we chose to combine both papers into one paper. But ideally, pure math is a paper of its own that is called paper 1, and applied math is another paper of its own that is called paper 2. But in this video, or in this first term, we chose to make section A be pure math consisting of 40 marks and section B be of applied math. But be rest assured that in second term these papers will be separated. So paper 1 will be a paper of its own and paper 2 will be a paper of its own, because by then you would have covered some good topics in both papers. So today we are going to look at how these questions which were given to you were answered and how you could get total marks. So question 1 says, solve for x, y, and z in the simultaneous equations. So this question was a little unique. It has 2 equal signs. One equation has 2 equal signs, as you can see it here. And what misled students was to equate. They would say this equal to this, they get an equation. This equal to this, they get another equation. And this equal to this, they get another equation. Then they tried solving those 3 equations and couldn't give any value. The equations were just vanishing. So how could you attempt such a question? The first thing, there are 2 approaches which are almost similar, but I shall look at both of them. So first of all is to let. So if you don't let, there is no way you can get a correct answer. So all students who never put this, let it be to a certain constant. It is not necessarily k. What we need is a constant. Some can put c. It is still okay. But if you don't let, just know that the solution will not come out. After letting, then you shall use the rule which you are taught, that the sum of all the numerators, you get the sum of all the numerators, which is this, and you also get the sum of all the denominators to give you the new denominator. So the new numerator is the sum of all the numerators, and the new denominator is the sum of all the denominators. Still, it is equal to k. That is the rule. That is the rule. So you needed to know that rule for you to solve such a question. But we shall see how you can bypass this rule in the second approach. After that, it becomes simpler because x plus 2x gives you 3x. What I did, I factorized out 3, but that's where the 3x comes from. Then 2y plus y is 3y, that's why the 3 is here. Then 2z plus z is equal to 3z, that is why the 3 is here. The reason why I factorized 3 out is to get something similar to this. So that is also another principle, that after getting the new numerator and the new denominator, the new numerator must be close, must be equal to, must have a factor of the second equation. It is a rule. All questions set in this form, that is the rule to be followed, that after adding, what you get after must have a factor which is similar and exactly similar to the second equation given. So when you realize that, you are going to substitute where there is x plus y plus z, we shall put 2. So let's do that. So it becomes 3 times 2 over 6. So 3 times 2 is 6 over 6 to give you 1. So the value of k is 1. After getting the value of k, you can now get your 3 equations. You'll now say, for example, remember now we have got k which is 1, so you shall come and say this one equal to this, equal to 1. What will happen? You'll cross multiply to give you x plus y, which is here, then this negative 3 multiplied by 1 to give you this negative 3 you see here. That becomes equation 1. Do the same for this, equate it to 1 to give you the second equation, and this also equate it to 1 to give you the third equation. Now those are the 3 equations which you need to solve simultaneously in a normal way. So it is you to choose what you want. You can use elimination method or substitution method. For me, I prefer elimination, so I'll come and say, what if I want to eliminate y? What will I do? I'll come at equation 1. Equation 1 has 2y, but equation 2 has y. So what I'll have to do, I have to multiply 2 throughout this equation so that I'm able to eliminate y. So now that's where this statement comes from, equation 1 minus 2 times equation 2. Now this statement is not a waste of time. Some students choose to just ignore it and go straight from here to go to this step. That is not okay. You have to write it, because in math your work has to be self-explanatory, especially in an exam. So when in an exam, make sure that what you write is self-explanatory. Someone can look through it and understand what you meant. So if you write something whereby a teacher has to call you to explain what you wrote, then just know that you are missing marks. So this statement is vital. It tells you what you are going to do. So it says equation 1 minus 2 times equation 2. So equation 1 is here. Then equation 2 is here. I have multiplied 2 throughout to give you 2y plus 4z equal to 8. In that case, I can subtract the 2 and cancel the y. It is not a must that you should eliminate y. It is what I've chosen. You can choose to eliminate x, but the problem, if you want to eliminate x, then you have to use equation 1 and equation 3. So if you chose 2 equations, 1 and 2, then by all means you have to eliminate y, because y is what is common in both. So when I do that, I'll come up with equation 4, which has x minus 4z equal to negative 11. Now this equation has x and z, and also equation 3 has x and z. So I can choose to eliminate any of the two. I can eliminate z or eliminate 2x first. So before we go to the next slide, let's see marks for this slide. Method mark was for you to realize that the new numerator is the sum of the 3 numerators, and the new denominator is the sum of the 3 denominator. That's where the first mark could come from. The second mark was to get the value of k. And the third mark was to substitute the k and get the three equations. All these three equations, when seen, that's when you get the M1. Then the third and the next mark will be got in this other slide. So in equation 3 and equation 4, I've chosen to eliminate z by multiplying through 4 throughout equation 3. Remember, if you look at this equation 3, here if I want to eliminate z, here there is z, but here there is 4z. So I have to multiply 4 throughout equation 3. That is why you are seeing me here. I'm writing that equation 4 plus 4 times equation 3. So when I do that, I can easily eliminate this by subtraction, because this is negative, this is positive. Sorry, by addition. So here it is not minus, you make it addition plus. So when I add this and this, gives me 9x, and this gives me positive 9. And when I make x the subject, x will be 1. Okay, so after getting 1, I'll go back and in equation 1, because if you look at equation 1 has x and y. So I've got x, meaning that when I substitute for x, I can get the value of y. So I'll come back here and substitute for x, then get the value of y. What about equation 2? If you look at equation 2 has y and z, but I've got y, meaning when I substitute for y, I can get the value of z. So I'll come back here and substitute for y, then get the value of z. So those are the three values they wanted: x, y, and z. And that was approach 1. What about approach 2? Approach 2, still you cannot bypass the first statement of equating to a certain constant. So always that is a must. When you don't see you equating to a constant, then there is no way you can get correct values of x, y, and z. Now to bypass the other rule of new numerator and new denominator, you are going to equate each to k and get equation. So equate this to k to get equation 1, this to k to get equation 2, and this to k to get equation 3. So I'm going to solve this one simultaneously to get the value of k first, then I can get the other values. So I'll get x in terms of k, y in terms of k, and z in terms of k. So I'll begin by equation 1 and equation 2. Equation 1 is here, and equation 2 is here. So we shall still follow the same procedure, because I will have to eliminate y. So when I do that, I'll come up with x minus 4z equal to negative 11k. Then equation 4 plus 4 times equation 3, I think we'll remember these steps, we went through them in the previous approach. So I'll come up with 9x equal to 9k, which gives me x equal to k. After getting x equal to k, I'll come back to equation 1 and substitute for x, then get the value of y in terms of k. Then come to equation 2, substitute for y to get z in terms of k. Then I remember my second equation given in the question, x plus y plus z equal to 2. Then I'll substitute for x, y, and z. Then I'll simplify it to get the value of k. After getting the value of k, I'll come back here and substitute x, substitute for k to get x equal to 1. In y, substitute for k to get y equal to negative 2. And in z, substitute for k to get z equal, so this should be z equal to 3. And that's what they wanted. So here M1 was solving to get the values of x, y, and z. and A1 was for all values correct. So all these X, Y, and Z were supposed to be correct for you to get A1. If one of them is not okay, then you don't qualify for this accuracy mark. So that's how you could get the 5 marks in question 1. Now let's go to question 2. Question 2 part A says, show that log base A of B over C is equal to log base A of B minus log base A of C. Then part B, hence solve the equation this minus that equal to 1. So let's start with part A. For part A, we are going to let this be equal to X and this be equal to Y. That implies that in this one, if I want to eliminate X, I'll say A to power X is equal to B, which gives equation 1. That is the rule in logarithms. Then also Y equal to A log base of C. To eliminate, I'll say A to power Y is equal to C, to give you equation 2. So I've got B, I've got C. So I'll come and get, but in this required proof there is B over C. So I'll come and say divide equation 1 by 2, so that I can be able to get B over C somewhere. So B over C is this, then B is equal to A to power X, which is there, C is A to power Y, which is there. Then I'll use the rules of indices, that when I'm dividing same base, I subtract the powers to give you this. And from there, I'll put log base A on both sides to give you that. Then this one can come here because it's a power. That is also a rule in logarithms. Now this one, there are same values, meaning it cancels. It is equal to 1. So that's why you can get X minus Y. But remember, your X was this and your Y was this. So meaning we have got the proof we want, that log base A of B over C is equal to log base of B minus log base A of C. That was part A. So part A, the first mark came from the division and the second mark came from the required expression. Now we shall go to part B of hence solve this. Now this word hence means if part A is not correct, then part B can never be correct. That's what hence means. And it means that you have to use the expression got in part A to look for a way of getting the solution of part B. So the hence means, first of all, if part A is not correct, part B can never be correct. 2, hence means that what you have got in part A must be used to get the solution of part B. If it is not used anywhere, then it can never be correct. So part B, that is what we are given, and we saw that this is the same as division, so division of this over this. So there I've used what I got in part A, so I can proceed. To remove the logarithm, I'll say 10 to power 1 is equal to this fraction. So that's where some students will go off from. They would say the whole of this is equal to 1, which is never okay. So to remove the logarithm, say this base to power this is equal to that. Then I can cross multiply to get rearrange to get a quadratic equation, which I can solve either by bulldozer method or by factorization. So if I choose bulldozer method, I'll come up with the 2 values of X. And that's what they wanted. So method mark was to combine the logarithms. When I see this when I see you combining this, I'll give you M1. Next mark will be on seeing the method used to solve the quadratic equation. So some students have good calculators. I'll call them good because they can easily solve this quadratic and give you the final answer. I think realize that when you do that, you are missing this mark. And because you're missing this mark, even the accuracy will be wrong, however correct it is. Because we don't know where you got the value from. Did you copy from your neighbor? We don't know, so you have to just cross. Therefore, make sure you show the method used to solve the quadratic equation, either bulldozer or factorization. But bulldozer is a little simpler. Then the last mark was for both values correct. So that's how you could get this 5 marks in question 2. Then question 3 says, if alpha and beta are roots of the equation this, form an equation whose roots are this and that. So just start from the given equation. The given equation is that. Then you have to divide by 2 to make this coefficient of x squared positive 1. Then you can say that this one is the sum of roots and this is the product of roots, negative of this. Because the equation is x squared minus sum of roots times x plus product of roots. So the negative of what is here becomes the sum of roots, and this one becomes the product of roots. So alpha plus beta is negative of negative 2 to give you positive 2. And alpha beta is 5 over 2. Okay. Then we can go back to the new roots given. Get the sum of the new roots. So for the new equation, the sum will be this plus this, which is here. Rearrange, get this and this to give you, to put there, and this with the powers to give you that. Then I think you remember the expression of this alpha squared plus beta squared. It gives you this alpha plus beta everything squared minus 2 alpha beta. Now I've got, remember alpha plus beta is this and alpha beta is this, so I'm going to substitute for alpha plus beta, and alpha beta. When I use a calculator, I'll come up with positive 1 as the sum of new roots. Then when it comes to the product, I'll multiply these 2, open brackets. So this times this gives you this, this times this gives you this, and this times this gives you that, this times this gives you that. So that was expansion. Then you have to rewrite this. So alpha cubed plus beta cubed can be written in terms of sum and product in this way. It is alpha plus beta everything cubed minus 3 alpha beta multiplied by bracket of alpha plus beta. It is a rule that in algebra. Then there is this alpha beta, don't forget it. Then from there you can now substitute product, sum, product, sum, product to give you 7 over 4. Okay, now that I've got product and sum, I can get the required quadratic equation by substituting the sum and the product. Then multiply through by 4 to get the quadratic equation they needed. So first mark was to get this sum and product of the given equation, that is B1. Then next we look for the sum. Have you got 1? Yes, we'll give you another mark. Next we look for this product, substitution and output to give you M1 and B1. And the last mark would be for the required quadratic equation. So that is how the 5 marks would come about. Then question 4 says, show that if the equation this and this have a common root. then this is equal to that. So shall come and first let the common root to be m. Then from there, this equation, where there is x, you put m. Even here, where there is x, come and put m. Okay. Then eliminate m squared to remain with m alone. That can be done by saying equation 2 minus equation 1. Now, why are we saying equation 2 minus equation 1 instead of equation 1 minus equation 2? Equation 1 minus equation 2 would also be okay, but if you look at this expression, we have b minus 1. Now, b is in equation 2 and 1 is in equation 1. So for you to get b minus 1, it has to be equation 2 minus equation 1. So that is why we chose that order. So when you do that, you shall come up with, this one cancels, then you come up with am minus m. M is common, that's why you have here 1 minus m in brackets multiplied by m. Sorry, 1 minus a in brackets multiplied by m. Then here we have b minus 1. So we have got something similar to what we have in the proof. Then make m the subject, because m, if you look at this expression, m is not anywhere. So you have to make it the subject so that it can be eliminated. So to eliminate m, you substitute this m either in equation 1 or equation 2. Whatever you choose, you'll get the output they want. So let me choose equation 1 and substitute for m to give you that. Don't forget the negative. Okay. Then from there, I'll try to multiply through by the LCM. LCM is 1 minus a squared. Don't forget the square, it is squared. So 1 minus a squared multiplied by the whole of this, the denominator goes away to remain with this alone. Then 1 minus a squared times this one, remember the denominator has 1 minus a, so the power goes away to remain with this. Then 1 minus a squared times 1 gives you that. Then 1 minus a squared times 0 gives you that. Okay, now I think you realize that I've got some b minus 1 somewhere. So I have to work on this other one to look for a way of getting this. So in this other one, we have a minus 1. What we are going to do, we are going to first take everything the other side, because this side is already okay. Now we have to deal with this other side. So we have to take all these other terms to the right hand side, which I've done here. Then I will factorize out 1 minus a is common in both terms. So factorize it out. When I factorize out 1 minus a here, I remain with a in brackets b minus 1, which is here. Then here 1 power will go, then you remain with 1 minus a. Okay, then this box bracket can be simplified ab, then a, then here negative 1, and here positive a. Okay, then here this and this cancels, so we're going to remain with ab minus 1, which is here. But in our proof, we have a minus 1 and 1 minus b. So what should we do? What we are going to do, we are going to factorize out negative 1 in both. So here, factorize out negative 1, it becomes this. Then for this one, factorize out negative 1, it becomes that. And the negative times the negative will give you a positive. So in the end, we will come up with what they want. So how do the 5 marks come about? 1 mark for eliminating m squared, and the output to get m, which is that, expressing m in terms of a and b. The another mark would be to substitute for m either in equation 1 or in equation 2. Then the 4th mark would be to factorize, and the last mark would be on the required expression. So that is how the 5 marks would come about. Then question 5 says solve for x in this equation. So one thing you should realize is that this is the same as this. Now some students did not realize that, and they went ahead to get the LCM, multiply by the LCM. It is a correct math, but it will not give an answer because the root, it will now give you x to power 4. Yet calculators can solve up to x cubed, common calculators. So what we are supposed to do was to let an y be equal to this. Then we come and substitute. So I think now this is a little simpler. So I'm going to first solve for y, then I come and substitute for y, then solve for x to get what they want. So to solve for y, multiply, get LCM. It gives you this, so 3y divide by 3 is y times y is y squared. 3y divided by y is 3. 3 times 84 is 252. Then cross multiply and rearrange to get a quadratic. Then solve that quadratic. The method used to solve must be same. And get the two values of y. So for each value of y, I have to get the corresponding values of x. So when y is 21, come and substitute for y here and get the corresponding values of x. Then when y is 12, substitute and get the corresponding values of x. So that is what they wanted. So M1 was this quadratic equation, that is B1. Then another B1 for both values of y. Both of them have to be correct. M1 was mobile, it can be put here or here, as long as you show the method of solving the quadratic equation. Then A1 for the first two values of x and A1 for the next two values of x. So that is how the 5 marks would come about. Then question 6 says solve the simultaneous equations, this and that. So for one, you should realize that all these equations have different logarithms, have different bases. So you have to change them to a common base. And which common base should you choose? Because there is base 3, base 27, and base 9. So always, of the 3 bases, you look at the one which is smallest. So 3, 27, and 9, 3 is the smallest. So we have to convert the rest to base 3. So let's start with the first equation. Convert this base 27 to base 3 in this form. Then simplify. So 27 is the same as 3 to power 3. That's why you're saying here 3 log base 3 of 3. Then this becomes 1 to give you that. So this becomes 1, and this with this remain with 2. That's why you see 2 here. So that gives you equation 1, all in base 3. Then go to equation 2. Equation 2 still change base 9 to base 3 and simplify to get equation 2. Okay, now I have 2 equations, but you realize that in equation 1 there is log base 3 of x, and here there is also log base 3 of x. Okay, in equation 1 there is log base 3 of y, and also here there is log base 3 of y. So that makes it a little simpler, because I can just eliminate log base 3 of y so that I can be able to get x, then also eliminate log base 3 of x to get the value of y. So let me start by eliminating y, log base 3 of y. So how will it be done? If I want to eliminate y, here there is 2 and here there is 4. That is why I have to multiply 2 throughout this equation 2 to get, so that I can eliminate the log base 3 of y. So when I do that and I subtract, this will cancel. I'll remain with this 6 of this minus 2 of this to give you 4. Sorry, this was 12 because 2 times 6 is 12. So 12 minus 2 gives you 10. That's why you see 10 here. Then this was multiplied by 2 to get 14. So 14 minus 9, it gives you 5. Okay, then I can take this 10 this side to get a half. Then 3 to power a half gives you x. And any number to power a half, it means the square root of that number. So x is root 3. But you need to be keen, we don't put plus or minus. So when you put plus or minus, you have lost that mark, because we are dealing with logarithms, and this value of x cannot be a negative. Then now I'll go and eliminate log base 3 of x. But here I have 2 and here I have 6, so I have to multiply 3 throughout this equation 2. That's why you see this word 3 times equation 2. So when I subtract the 2, I'll say this will now be this minus this will cancel. Then here 2 minus the order, I reversed the order. It is this one minus this. So this 2 minus this 2 with a 3 gives you 6. So 6 minus 6 is 0, so it cancels. Then this 12 minus 2 gives you 10, which is that. And this 18, this is 3 times 9, which is 27. So 27 minus 7, it gives you 20. So still do the same. Take this 10 this side and making y the subject means 3 to power 2 is equal to y. So y will be 3 to power 2, which is 9. I think that's what they wanted. So the first mark was to see this equation 1, changing everything to base 3 and get an equation. Second mark will be an equation 2, changing everything to base 3 and get an equation from this. Then M1 was for solving this to get x. M2 was for another M1 was for solving this to get y. Then A1 was for both correct. So if, for example, you solve this correctly and get a correct value of x, but here you fail to solve it, it means this A1 cannot be got, and this M1 can also not be got. So that is how the 5 marks came about. Then question 7 says, for what values of m will the equation this have equal roots? So this is have, not has. So here we shall say this is the quadratic equation. So for equal roots, b squared minus 4ac is equal to 0. So b is this coefficient of x, and a is the coefficient of x squared, and c is the coefficient of this one without x. So substitute for b, for a, and for c. Then look for simplifying. So what I've done, this square with a negative, it becomes positive. Negative squared becomes positive, so it gives that. Then expand this square. Now what we have done here, 4 is common, so it can cancel. When it cancels, here we shall remain with this squared, which is this. Then here we shall remain with minus 7. So 7 times 3, it gives you 21, but there's a minus, which is that. Then negative 7 times 2m to give you negative 14, equal to 0. Then you have to collect like terms to get a quadratic equation. And we solve that quadratic equation to get the two values of m. And that's what they wanted. So M1 was for substituting into the condition for repeated roots. Another M1 was for expanding everything, this and that. Then another B1 was for getting a quadratic equation in a simplified form. M1 for solving that quadratic equation, and A1 for the two values of M. So that is how the 5 marks came about. Then question 8, find the greatest value of the curve this and the value of x at which it occurs. So we shall first let that expression be equal to y. Then we factorize out the coefficient of x squared. So what I've done, I've rearranged this to give you that. Then I factorize out -2 in these two coefficients, in these two values which have terms which have x. It is okay to include also 1 in the factorization, but what we are interested in when we are completing squares are the two terms, one of x squared and another one of x. That is why I chose to leave out this 1. Then from there I have to complete squares. Complete squares, different schools teach it differently, but they still come up with the same output. Now for us, this is how we teach it, that when we get this, to complete squares means it will become x minus half of this, everything squared, minus the square of what you put here. When you do that, you have completed squares. Of course, there are various ways to get it, but that is the logic behind completing squares. And that is what we are going to use when it comes to this. I think you realize that now b is 2. So where there is b here, we shall put 2. And when we do that, we shall come up with this expression. It becomes, so b is 2, 2 over 2 is 1. That is why you see 1 here. 1, and that's why you see 1 squared here. So there we have completed squares. Next is to simplify. So this, open this box bracket, this by this gives this, this by this gives you this, and there's this one here which was here to give you that. So in the end, you shall come up with that. But they ask for the greatest value. Greatest value means the one which has the power, you equate it to 0. So it becomes -2 times 0 plus 3 to give you 3 as the greatest value. Then the value of x for which it occurs, it means come at this and equate to 0. Then get the corresponding value of x. And that's what they wanted. So M1 was for factorizing, M1 for completing squares, then simplified output, then the greatest value, stating it, and also stating the value of x. And that's how we could get the 5 marks. So I believe you have seen how you could get the 40 marks of section A. That is pure mathematics. And now we are going to look at how we could get these 48 marks of section B, which was applied mathematics. So we shall start with question 9. So before we start, I will remind, in case you are hearing some background noise, I request you to just bear with it because it has begun raining this side, and yet I have to upload this video because we need the solution. So we shall try our level best to reduce the background, but in case we can't eliminate the whole of it, just bear with it because we have to make the video and it has to end. So let's start with question 9. Question 9 says the diameter of oranges to the nearest centimeter were these ones. Determine the mean of the median of the oranges, standard deviation of the diameter of oranges, 4th to 9th decile range of the diameter of oranges. So elementary statistics, this topic is under elementary statistics, but remember it is divided into two parts. There's what we call ungrouped data and this is what we call grouped data. So this one is ungrouped. I think we'll see it is 1 value of x. The reason why I'm telling you that because they are treated differently. So this is ungrouped data. We shall also see grouped data as we go on in this video. So let's start with question 1, where they want the median, the mean. So here you have to, it is advisable that you tabulate since it has frequency. It is true it is ungrouped data, but it has frequency. So you shall first write all the values of x and the corresponding frequencies as given in the question. Okay, now we need to add all these values and get the total frequency, which is that 120. Then because they asked for mean, we need a column of fx. So I have to multiply this and this to give you that, this with this, 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 and this with this. Then I have to add up all these values to get the total. So be keen with the calculator, because some of you know the concept, but you were adding wrongly. So make sure you add carefully so that you don't lose marks. Then because they ask for standard deviation, we need a column of fx squared. So fx squared, it is this squared times this. It is still okay. So 8 squared times 9 gives you that. 9 squared times 15, 10 squared times 21, 11 squared times 32, 12 squared times 19, 13 squared times 13, 14 squared times 11. Okay, then you still get the calculator, add up all these values to get that total. Okay, now because they ask for the decile range, we need a column of cumulative frequency. So first value put there this. The 9 plus 15 gives you 24. 24 plus 21 gives you 45. 45 plus 32 gives you 77. 77 plus 19 gives you 96. 96 plus 13 gives you 109. 109 plus 11 gives you 120. And that will be the column of cumulative frequency. So now that we are done with tabulation, we shall start our solutions. Roman 1, they wanted the mean. So mean diameter, the formula is summation fx over summation f. Summation fx is this, summation f is this. So divide the two to get the median. So that was Roman 1. Roman 2 is standard deviation. So before you go to the next slide, let's first see marks for this slide. So the first mark was for values of this when they are correct. Next mark was for values of this if they are all correct. And the third mark was for values of CF if they are all correct. The next was M1 was for this division, A1 was for the output. Okay, now we can go to the next slide and see how to get the standard deviation. One, we need to know the formula for standard deviation. It has a square root. Most students forgot the square root, but if you don't put a square root, it becomes variance. So put a square root, then substitute summation of fx squared over summation f, summation of fx over summation of f, everything squared. Most students forget this. Then use the calculator to get this output. That was Roman 2. What about Roman 3? For Roman 3, they said 4th to 9th decile range. So we need to get the 4th decile and the 9th decile. The first thing to do is the position. So the 4th decile position is 48, meaning that the 4th decile is 11. Now, how did we get 11? The first thing to do is to get the position. 4th decile is 4/10 of the total frequency, which is 120, to give you 48. After getting 48, come and locate where 48 is. This is 45, meaning 48, and this is 77, meaning 48 is within this. So that means that you draw a line and get the corresponding value of x. So the 4th decile is the value of x corresponding to the 4th decile position, which is 11. That's why you saw us say that the 4th decile is 11. What about the 9th decile? So 9th decile position is 9/10 of the total frequency to give you 108. Then do the same, come and look for 108. This is 96 and this is 109, meaning 108 is within this 109. Therefore, draw a line and get the corresponding value of x, which is 13. That is why you saw us say that the 9th decile is 13. Remember, we are under ungrouped data. If this question was grouped data, then the working would be a little different. But for ungrouped data, this is how we get the 4th decile and 9th decile. But they asked for range. So come and see that the 4th to 9th decile range is D9 minus D4, which is 13 minus 11 to give you 2. And that's what they wanted. So for this slide, the first mark was to see this substitution inside the square root. Why? Because some students forget to put a square root, but they know this formula. So there you get 1 mark and you lose the others. Okay, but if you remember to put the square root, then you get the 2nd mark. Okay, then the 3rd mark is if you can use the calculator correctly to get a correct output. So when I see this value, that's when you can get the A accuracy mark. Okay, then for this Roman 3, B1 was to see this value of 4th decile, another B1 for the value of the 9th decile, M1 for subtraction, and A1 for the output. So that is how you could get the 12 marks in question 9. Now let's go to question 10. Question 9 was for ungrouped data. Question 10 is for motion in a straight line. So part A says A, B, and C are 3 points lying in that order on a straight line. Okay, a body is projected from B towards A with a speed of 3 meters per second. The body experiences an acceleration of 1 meter per second squared towards C. Now this is what made the question tricky, because the body is projected towards A, yet the acceleration is directed towards C. We shall see how to deal with it. If BC is equal to 20 meters, find the time taken to reach C and the distance traveled by the body from the moment of projection until it reaches C. That is part A. Part B, A, B, and C are 3 points which, okay, I think it's better to first go through part A since they are independent. So for part A, we need to make a sketch. Mechanics, you cannot run away from sketches. drawn with a ruler. So shall come and first locate our 3 points A, B, and C. Then we put the velocity and also the acceleration. So the body is projected towards A, so it will go in that direction. But because the acceleration is in the opposite direction, it will be opposing the motion. So along the way, the body will be momentarily at rest and it will turn and move in the opposite direction. So this can be understood from, I think you remember in O level you did motion under gravity, where they projected the body up and along the way it is momentarily at rest, then it comes back downwards. Now why was that so? This is what would happen. Velocity was upward, okay, but acceleration on this body was due to gravity. And remember, gravity is towards the ground. So acceleration was towards the ground, yet velocity was upward. That is why as the body moves up, it would be opposed by this acceleration due to gravity until it is momentarily at rest. Then it comes down. That explains why if you get a stone and you throw it up, it has to automatically come down, because as it goes up, the acceleration due to gravity will oppose its motion until it cannot resist the gravity, then it comes downwards. Okay, that is to explain something about this one, because it is somewhat similar, only that this is vertical motion, yet this is horizontal motion. Okay, they told us the distance between B and C is 20, that's why we put 20 there. So one, they wanted the time and also the total distance covered. So for motion BSC, from here through B up to C, what will happen? The displacement is negative. Why is it negative? Because initially at the point of start it went to the left, meaning the displacement to the left is positive, but it came back past the point of projection and went further away in the opposite direction in which it had started with. So at first the motion was to the left, but now after that it is to the right. So we all know that change of direction is denoted by change of sign. That is why we are taking motion to the left, to the right, to be negative. So that also disturbed students and they could not realize the negative. Okay, then also here I think realize that this is to the left, which is positive, but this is to the right, so it will be negative. Okay, so velocity is positive because it is to the left, but acceleration is negative because it is to the right. So when you realize that, then next is easier, because you have to quote the second equation of motion and substitute for S, for U, and for A. I think T is the only unknown, so we can simplify, we can solve that. That is a quadratic equation. Show the method of solving and then get the two values of T. But one is negative and the other is positive, so you eliminate the negative one and conclude with the positive one as the time. What about the distance? So for motion BA, we know this distance from B to C, but from B to A, we don't know it. So we have to first get it. So shall use the third equation of motion and make S the subject. So final velocity is 0, because at this point it is momentarily at rest. Initial velocity was 3 and acceleration is -1. So you come up with 4.5. Okay, now there is what we call displacement. This was displacement, but now they want distance covered. So distance covered, it first moved, so from here to it is 4.5. It first moved from B to A, which is 4.5, then A to B, which is another again 4.5, and B to C, which is 20. So you have to add all those distances to give you 29. So that was part A. Let's first see how marks were distributed. So this is for substitution for S, U, and A. Then showing the method of solving the quadratic. And the conclusion. Conclusion means here you get two values, but you have to eliminate the negative and get and take the positive. So if you stop here by giving two values of t, then you lose the accuracy mark. Accuracy mark will be got by concluding. Okay, then this one also getting the distance BA, then M1 also adding all the distances, and A1 for the output. So that's how you could get the 6 marks in part A. Now let's go to part B. So part B says A, B, and C are 3 points which lie in that order on a straight road with AB equal to 95 meters and BC equal to 80 meters. Okay. A car traveling along the road in the direction ABC with acceleration A. A car is traveling along the road in the direction ABC with acceleration A meters per square second. The car passes through A with a speed U, reaches B 5 seconds later, and C 2 seconds after that. Okay, find the values of U and A. So here there was also a trick. We are going to look at it. So first of all is to sketch. So in mechanics you have to sketch. We have ABC, then for AB the time taken is 5 and the distance is 95. For BC, time taken is 2 and the distance is 80. Now a car passes A with velocity U, then B we don't know, so we shall call it VB, and C we don't know, shall call it VC. Okay. Then for motion AB, we know the time, we know the displacement, and the initial velocity, so you can come and substitute in the second equation of motion. 95 U is what we want, T we know, A we don't know, and T we know. So that gives us equation 1. So I can choose to make you the subject and call it equation 1. Then for motion SC, now this is where the trick came from. Most students, after dealing with motion AB, they went to motion BC. And when they went to motion BC, the initial velocity the initial velocity they used was U. Yet for motion BC, the initial velocity was V. So that is where challenges came from. When you see that, just know it is not okay. So if you want to use motion BC, the first thing to do is to get VB, and that becomes your initial velocity. But to bypass that, you have to deal with motion AC. In that case, U will be the initial velocity. So for motion SC, the distance is this plus this, which is that, and the time taken is this plus this, which is that. Then you can quote our second equation of motion and substitute for S, for U, for T, A, T. Then you have another equation in terms of U and A. So you have two equations. This is equation 2. So you have equation 1 and equation 2. What we are going to do, we are going to substitute 1 into 2. Where there is U, we shall put that one, and remain with A alone. So look for a way of making A the subject. That is acceleration, but they also asked for the value of U. So I'll go back to equation 1 and substitute for A to get the value of U. So B1 was for the first equation, B1 was the next B1 was, second mark was for second equation, third mark was for substituting or solving, and next mark was for output, which is the acceleration. Then M1 for substitution, A1 for the output. And that's how you could get the 6 marks in part B to get 12 out of 12. Then question 11 says that table below shows the marks obtained by 100 students in a mathematics test. Okay, part A, calculate the model mark of the students. Part B, draw a cumulative frequency and use it to find Roman 1, the semi-interquartile range, and Roman 2, the range of the middle 40% of the marks. Okay, so when this is now group data, and each time you see inequalities, it means that the class is the same as the class boundary. So what we do, the first thing to do is to tabulate. We shall tabulate and the marks we shall put. Now here what we have done, we have combined the class and the class boundary. That is why you are not seeing these inequality signs. So each time you see the inequality signs, it means class is the same as class boundary. So it is advisable to put both in one column by removing this inequality. Then you can go to frequency. Frequency will write what is given. Then you can go to class width. Why are we getting class width? It is because here they told you to calculate the mode. But if you look at this, they are unequal classes with unequal class width, meaning for you to get the mode, you have to use frequency density. So that is the reason why you have to get class width. So class width is got by subtracting the lower class boundary from the upper class boundary. So 40 minus 20 is 20. 50 minus 40 is 10. 55 minus 55, it is 5. 60 minus 55, it is 5. 70 minus 60, 10. 90 minus 70 is 20. 100 minus 90 is 10. Okay. After getting class width, we can now get the frequency density, which is frequency over class width. So 5 over 20, 0.25. 15 over 10, 1.5. 10 over 5, 2. 15 over 5, 3. 25 over 10, 2.5. 25 over 20, 1.25. 5 over 10, 0.25. Okay, now this will be used to get the mode, but also if you look at here, they ask for semi-interquartile range, or they ask for cumulative frequency, meaning we need a column of cumulative frequency. So first write this frequency here, then 5 plus 15, 20, 20 plus 10, 30, 30 plus 15, 45, 45 plus 25, 70, 70 plus 75 plus 25, 95, 95 plus 5, 100. So that is what we wanted. So some students would go ahead to get x, fx, fx squared. That will be a wastage of time because fx is got when they ask for mean, and fx squared is got when they ask for variance or standard deviation. Now because they didn't ask, we don't need to get them. Okay, after tabulating, that is when you can think of answering the questions. Part A said calculate the model mark of the students. So I'll have to identify the model class. Now here we use frequency density. The highest is 3. Okay, after getting the model class, you can get the difference between the model class and the pre-model class. So 3 minus 2 is this. Then D2 or delta 2, model class minus the post-model class, which is 0.5. Then from there I can substitute in the code the formula for mod. This formula is available in your math logbooks, so there's no need to quote it wrongly. Now remember, I have got this as the model class. Okay, so the lower class boundary will be 55. D1 we got it as 1, and D2 we got it as 0.5. Class width, this is the class width of the model class, which is 5. So with that, you can use the calculator to get this as the output. So before I go to the next slide, let's see marks for this slide. So values for frequency density, that is 1 mark. Values for cumulative frequency, that is another mark. Then substitution and output. So that was part A. Part B, they want you to draw a cumulative frequency curve. So there we need a graph paper by all means. So come and get a graph paper. Then draw the axis. Leave 1 centimeter, draw the horizontal axis. 1 centimeter, draw the vertical axis. Then get a correct scale for the horizontal axis. So that all values can fit. Also get a good scale for the vertical axis so that all values can fit. And the graph has to be labeled. So in your O level, like I told you, in O level, we used to accept, here you put cumulative frequency, here you put upper class boundaries. But now here it has to put, you have to put what is in the question. So now question we had number of students, that's why you're putting number of students. And here we had marks, that's why you put marks. So here you have to put what was in the question. Then you have to start to plot. Plotting, most students plot wrongly. They plot lower class boundary. So this is lower class boundary and this is upper class boundary. So if you plot 20 with 5, that is already lower class boundary and makes everything wrong. It has to be upper class boundary. So I'm going to put 40 with that, with 5, 50 with 20, 55 with 30, 60 with 45, 70 with 70, 95 with 95, 90 with 95, and 100 with 100. So let's do that. So shall come and plot 40 will be 5, 50 is 20, 55 is 30, 60 is 45, 70 is 70, 90 is 95, 100 is 100. Next we have to draw a reasonably smooth curve through all those values, but the curve must not be left hanging, so it has to be elongated until it reaches the value of the lower class boundary. So we began with 20 because 20 was the lower class boundary. So let's do that. The curve must be reasonably smooth. So reasonably smooth means don't put your graph paper on a table. First put the answer sheets, then you put the graph paper, put the answer sheets on the table, then the graph paper on top of the answer sheets. In that case, the graph will be reasonably smooth. But if you put your graph paper directly on the table, remember some tables are rough. The curve can never be smooth or reasonably smooth. So always take note of that. So that was the part of drawing, but they also told you to use the ogive. If we go to this, they said part A, use the ogive to find semi-interquartile range and also the range of the middle 40% of the marks. So for the semi-interquartile range, we need to first get the positions. So I'll have to come here and get the position of the lower quartile. It is a quarter of the total frequency, which is 25. Okay, when I do that, then I'll come back to the graph and look for 25 from the vertical axis. It is somewhere there. Then draw a horizontal line to meet the curve. Then take a vertical line downwards to meet the horizontal axis and read off that value, and that will be your lower quartile. Okay, but we also need the upper quartile, so I'll come back and get the upper quartile position, which is 75. So I'll come back to the graph and locate 75. Then drop a perpendicular to meet the horizontal axis and read off the value. So that will be your Q3. So now that I have Q1 and Q3, I can get the semi-interquartile range. So I'll come and say that now the semi-interquartile range is Q3 minus Q1 over 2 to give you 10.25. That was Roman 1. Roman 2, they wanted the middle 40%. Middle 40%, now that is another way of asking questions about percentiles. So middle 40% means you have to first get the range. So how do you get the range? Remember, percentage is from 0 up to 100. 0, that is P0, up to 100. Okay, but they want the 40% to be in the middle, so you have to first get the midpoint. That is the midpoint, and they want 40% to be in the middle, meaning the 40% will be shared equally on either side. So the one side will take 20%, another side will take also 20%. Remember, this midpoint is 50. Therefore, to get this value, it will be 50 minus 30 to give you, 50 minus 20 to give you 30. So this is P30. That means one value they want you to get is 30th percentile. Okay, so this is 50 and this is 20. This will be 70. Or you can say 100 minus 20 minus 100 minus 30 to give you 70. So this is the range they want you to get. They want you to get 30th to 70th percentile. Now that we know that, we have to first get the position. So 30th percentile position is 30 over 100 times 100. This 100 is the total frequency to give you 30. So I'll come back here and locate my 30th position. Then drop a perpendicular to read off the value. So read off that value, and that will be your P30. What about P70? P70 still get the position, which is 70, and then come back here and locate it. Then you can drop a perpendicular and read off that value. Then you can come back here and answer, get the middle 40% range, and that's what they wanted. So let's see marks for this graph. So B1 for the axes, both axes were labeled. 2 marks for plotting points correctly, and B1 for a reasonably, not this word, reasonably smooth curve. It has to be smooth. Then when you come here, 1 mark for substitution and 1 mark for the output, correct, which is correct. Then 1 mark for subtraction and 1 mark for the output. So that is how you could get the 12 marks in this question 11. Now let's go to question 12. Question 12, part A says 3 boys are pulling a heavy trolley by means of 3 ropes. The boy in the middle is exerting a pull of 100 Newton. The other 2 boys, whose ropes both make an angle of 30 degrees with the center rope, are pulling with forces of 80 newtons and 140 newtons. What is the resultant pull of the trolley, and in what direction will it move? So this is about resolving. So let's first do part A. Part A, you had to make a sketch. You have a trolley, then you have the center rope, which is 100 newtons. Then the other 2, one is 140, which is 30 degrees to the center rope, and the other is 80, which is 30 degrees to the center rope. Okay, next is to resolve. So resolve this 140 horizontally, it will be 140 cos 30, vertically it will be 140 sin 30. Then this 100 is the entirely horizontal, so it is 100 and 0. Then the 80, the horizontal will be 80 cos 30, and the vertical will be negative because it is downwards, negative 80 sin 30. Remember, we have already covered on this platform the topic of composition and resolution of forces. So if you have questions about resolving, I encourage you to watch that video. And if you have challenges in locating a certain topic, it is advisable that you send a WhatsApp message on the contact I gave you in the first slide of this video. Then I can get for you the link of the video you want. So don't fear to ask. That is how you will benefit in this level or on this platform. So all messages I receive, I reply them, provided you want a link for a certain video. If it is there, I'll tell you. If it is not yet there, then I'll also tell you to wait a little. So after getting this is in vector form, so magnitude will be this squared plus this squared, everything under square root, to give you this as the magnitude of the resultant pull. But as for the direction, so direction you have to write positive horizontal and positive vertical. Then the line joining from start to the end will be the resultant force. And this is the direction they want. So we can get it using tan opposite over adjacent to give you that. So angles are to 2 decimal places. I think you realize here I used 4, but here I'm using 2. So the rest are 4 decimal places, but when it comes to angles, we use 2 decimal places. Then I have to conclude that the resultant pull on the trolley is this, in the direction 5.90 degrees to the center rope. Remember, the center rope was horizontal. That's why I'm using it. And towards which side? So this, because this can be this side or this side, but it's towards the 140 Newton. So that was part A. The first mark was for a correct force diagram. By the word correct, I mean you have to use a ruler to draw the force diagram. Then M1 was for resolving horizontally and get the output correctly. This was this M1. The another M1 was for resolving vertically and get a correct output. Okay. Then this M1 was for this substitution and A1 was for this magnitude. This M1 was for attempting to find direction, and the B1 was for stating the direction. So after getting this theta, remember to conclude, because that's where the last mark comes from. Okay, that was part A, and that's how we could get the 7 marks. Now let's go to part B. Part B, at time t equal to 0, two particles A and B have position vectors this and this. So this is position vector of A, position vector of B. A moves with a constant velocity of this, okay, and B with a constant velocity of this. Given that when t is equal to 5, B passes through a point that A passed through 1 second earlier. Now this is where the interpretation is needed. So let's say this is the point where B passes. So B will pass through that point when t is 5. Okay, what about A? They told us that A passed through 1 second earlier, meaning this A will pass through this same point when t is 4, because it should be 1 second earlier. So this was the trick in this question, otherwise it would have been okay. So here they simplified it by asking for velocity, by using the word velocity. But if they put the word speed here, you should remember that speed is the magnitude. But here they just said velocity, meaning you have to get your vector and you stop there. So let's see how it was done. So you have to first get the position vector of A, particle A at any time t, which is that initial position vector, velocity. Do the same for particle B, initial position vector, velocity. Okay, then they pass through the same point when time is t is 4 for A and when t is 5 for B. That is why we equate the two, because when t is 4, A is at point X, and when t is 5, B is also at point X. That's why we equate. Then you can substitute. Put 4 here and put 5 here. Then simplify. The left hand side gives you this. Then take this one this side to give you that. Then divide by 5 to get V. and that's what they wanted. So what I meant by speed, if they had asked for speed, you are supposed to continue and get the magnitude. But the good thing, they asked for velocity, so you stop there. So 1 mark was for this correct substitution of time and also correct substitution of time. So this was 1 mark, 1 mark, and the other mark was for equating the two. Then here for simplifying, and the last one was for that. So that gives you the 5 marks. So that's how we could get the 48 marks in this section B. I believe you have benefited. And that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on the marking guide for physics and of term 1 of senior 5. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so you can all benefit as a family. Remember, this is the family of victors, and I believe you will also excel if you use this YouTube channel very well and in a committed way. So we meet again in the next video.